Webinar, myself, David Gambarte, and my colleague, Abraham Martinez. You can maybe say hello, Abraham. So hope everyone can hear us well. Yeah.
Hello, everyone. Welcome to the webinar. It's a pleasure for us to introduce you all the products that in the acoustic imaging solutions that FLIR has. Welcome.
Okay, so welcome to this webinar for benefits of FLIR Acoustic Solutions in various applications. So the content of today's webinar is pretty simple. We're going to focus on showing the different acoustics products and portfolio, mentioning or discussing about their features, and also covering the different modes and scope of use of our acoustic cameras. We will then also talk briefly about another leg of our acoustic solutions, which is our FLIR Acoustic Viewer, our cloud software for storing analytics and reporting. And then we'll have a short final remark on our general advantages, like, let's say, characteristics of our cameras, like, in the market environment. So we start, as I said, with the acoustic products portfolio features. And first, before starting with existing products, we need to step back a little bit and show where we started with. Our first camera units, our first acoustic cameras, were actually having this kind of, as you can see here, this tracer battery with with a cable, which actually we still have some in the market, and we still have a lot of very let's say happy and satisfied users working with our camera. But then we realized that we had to make them more kind of easy and light to use, so to move around in industrial environments. So we changed our battery enclosure, and we changed the battery type, of course. So we started to have these camera models with a smaller battery in the base of the camera, in the base of the handheld. And then we started to develop different features. The very first camera actually we had was a camera for partial discharge detection, giving the PRPD pattern. And then we started to add analytics to our solution. After that, we developed our first camera for leak detection, focusing in compressor leak. Then we started to give some analytics on camera, and then along the time we have been building more and more different modes and features and benefits for customers. And now at the moment, as our current portfolio is, we have the SI2 cameras, which are like, we have different we have SI2PD, SI2LD, and SI2 Pro, and you will see them now in the next slides. Then we have the SI2X for hazardous environments. It's an 8X certified camera. And then we also have the SI1LD, which is a bit simplified camera with high-level features that are present in the last generation of our cameras, but focusing in leak detection and only in leak detection. As a big improvement of this, of the big development of this camera, this SI1LD, that is also present in SI2 and SI2X for those users that they already have the camera, is that we added the band path for frequency selection. So now users can have a frequency selection band path if they require it for their own work. So the FLIR SI2 series models, as I mentioned, they are SI2PD, SI2LD, and SI2 Pro. So SI2PD, it's a camera for electricity use. So it works finding, localizing partial discharges in medium and high voltage, giving the PRPD pattern, identifying the type of partial discharge, and then assessing them. So we give an assessment of the type of partial discharge and the severity level of the partial discharge with some extra recommendations in camera. Then the SA2 unit has leak detection for compressor, for gases, sorry, with a list of gases that actually allow us to give the quantification on a screen of the leak size of the gas. Good to remind here that this camera works for any kind of pressurized gas detection. So even if it's not listed in our gas, kind of like specs, the camera will find the leaks anyway, but we will not give calculations on the screen of the leak size and the leak cost, of course. And then this same camera, this is a 2LD, has a mechanical fault detection mode, which is basically spotting mechanical faults, potential mechanical faults, in bearings, conveyor belts, motors, gearboxes, any kind of rotational elements in industrial environments. The camera will actually find where there's a potential mechanical fault and give, of course, the decibel level of the mechanical fault, where like it allows you to use the comparison method or basically use our analytics with the crest factor and kurtosis statistical indexes, and make your own decisions on the maintenance of your systems. And then we have the SI2 Pro, which is actually combining all the features and modes of the two previous models. So SI2 Pro is the most advanced camera that we have in this. Like as a parallel models of cameras, we have also the ATEX certified models, which are the SI2X Pro, which is combining everything as the same way as the SI2 Pro, and the SI2X LD. They are both ATEX certified, and they are ready to work in hazardous environments. So of course, in these cases, the cameras are more intended to be used in like manufacturing industries where actually they are present in these hazardous environments, or in mining, or in oil and gas, or in any places where these kind of models are required. Now we are jumping into the SI1LD, which is our newest camera, and my colleague will continue from here.
Yes, well, the SI1LD acoustic imaging camera is basically our newest model. So this is meant for compressed air leak detection. It follows similarly the same design guidelines that we are characterized. So you can expect from this camera the same seamless user experience, and also to spot the leaks in an instant way. So it's very simple, efficient, and impactful. In that way, we can pinpoint leaks in the noisiest environments with minimal training. The characteristics for this camera is that we have a frequency range from 2 to 100 kilohertz, and as well as 96 microphones and optimized array. Also in the looks, you can see that pretty much is similar to the SI2 series, but of course this has notable differences in the design and also in the software. So, well, we are introducing also the manual frequency selection, which is the bandpass filtering, and this bandpass filtering allows the user to select frequency ranges or ranges of frequencies where they want to inspect the phenomena. We'll touch into this point in a later time, but yeah, well, we are introducing this feature in this series, also in the SI2, of course, series. And this device is also compatible with our offline and online solution. So you can expect that this, of course, can be compatible with acoustic FLIR viewer for reporting, as well as thermal studio, the offline solution.
Yeah. So now we're jumping into the filters. So one of the main advantages or benefits of acoustic imaging cameras is the powerful filters that we have, right? So basically, the main idea is that we are filtering out, that means discarding all the non-relevant sound in any industrial environment or in any kind of environment where there are sounds around that are not relevant for our inspections. This filtering is basically, is representing actually the biggest development that you can actually find in an acoustic camera. So we have different filters for the cameras, we basically divide in three kind of filters: a normal, high, and ultra. But then we actually have our models with auto filter, which basically means that the camera will select the best frequency range, not even filter, the frequency range for the specific sound that we are looking for, and will actually discard all the sound that is actually happening in other frequency levels. In addition to this, we also have, as you can see here, we have like this icon below this auto, which is the auto filter mode. We have also the frequency path. So we have a frequency path where you can actually yourself manually select the frequency range and work with the data actually thrown by the camera. So as I said, even though we have different filters that will actually give some kind of manual independence to the customers or to the users, our two main characteristics in cameras, or our two main battle horses for the camera use, are auto filter, which is like clearing up everything and just focusing on the specific phenomena that the user is looking for. In this case, we just as a reminder, partial discharges, leaks, gas compressor leaks, steam leaks, or mechanical faults. But if the customer, for any reason, wants also to use the manual frequency selection, because they want to go further in the analytics, they want to get narrow data on the specific frequency ranges, they can also select the manual filter and select the frequency in camera on the screen. Also good to reminder that in the SI1 unit, we have only high frequency filter, which is like one specific filter for a specific frequency range work, and manual filter.
Yes.
That in SI2 units, we have all the filters available for the customers and the users. So if we would like to summarize what our cameras have in terms of features, characteristics, this is basically our slide, right? So we have cameras that work from 20 Hz to 130 kilohertz. I'm talking about the SI2 now. SI2 series work from 20 Hz to 130 kilohertz with 124 microphones, with working operational distance up to 200 meters. Which is actually giving a big advantage to many customers that need to work in distance, like long distances, for example, for overhead lines inspections over the road, or for working in hazardous environments where they don't want to step, or it's very expensive for them to step into different places. They need to take distance to make the inspections. They can do it with our cameras. And of course, this is lowering the risk level of any kind of inspection, because you don't need to get that close to the system. So of course, you don't need to even touch them, but you can actually take distance from them and perform your inspections. Then we have 12 megapixels color visual screen with quite powerful per 8 digital zoom. We have 4 frontal LED lamps, display of 1280 per 720, so 5 inches display. We have this is SI2 auto filter mode, which is, as I said, a big advantage. We have auto distance up to 5 meters, and of course advanced AI filtering. So we basically do filter the non-relevant sound from any kind of environment. We have three main modes. Make mode for faulty rotational mechanical elements, PD mode for finding, classifying, and assessing, so giving the severity level of the partial discharges, different kind of partial discharges, not only corona, any kind of partial discharges. And we have leak detection mode for compressor and for industrial gases. As I said, the camera find any kind of leak from pressurized systems of any kind of gas. But if we want to get calculations, we have a list of gases that actually allow the camera to calculate the leak size and the leak cost. But if you're looking for example, well, gases that are not listed here, we have an example of chlorine in a later slide. The camera finds the leaks in the same way, but the quantification is not there. That's the only difference. We have QR code reader, we have Wi-Fi, and USB exporting, so we have two ways of exporting data, and also, of course, connecting the camera to the net. And we have the FLIR Acoustic Viewer as a big tool for us, with unlimited storage and a limited number of users, and with very powerful insights for reporting and reporting tools. Then if we go to the SI1, we're talking about 20 to 100 kilohertz, a bit shorter frequency range. Actually, this is due basically to the scope of use of the camera. So this is for leak detection. So basically, we don't need to go that high in the frequency range. This camera has 96 microphones, which is actually also a big improvement in terms of the optimization of the microphone array. We work up to 130 meters distance, so this is having a less distance performance than the SI2. But again, like if you think about 130 meters, we are talking about a very long performance for an acoustic camera. So 130 meters in an industrial environment is an extremely long distance. There are not many places where you can actually make the camera to work in those distances. We have the same kind of screen, so 12 megapixel with per 8 digital zoom. So we have frontal LED lamps the same way. We have 5 inches display. Sorry, this is a mistake. We don't have auto distance in the camera. So yeah, sorry, it's my fault. Yeah, we do have auto distance up to 5 meters. I was mixing with auto filter. Sorry, that's my bad. So we have auto distance in the camera up to 5 meters, and of course, advanced AI filtering. We have manual frequency selection with advanced band filter. We will show it later. And we have one filter, the high frequency filter. We have LD mode, basically it's one mode camera with leak size quantification on the screen for compressor. So we will give the quantification of the leak size in compressor only, but we find any kind of pressurized gases leaks. So the only thing is that we don't give the quantification of the leak size. So for leak finding, it's a perfect camera as well. So we have QR code reading, a Wi-Fi and USB exporting. And we, of course, have at your disposal the FLIR Acoustic Viewer, as we do have for all of our acoustic cameras. Maybe Abraham can take care of this now.
Yeah, and then in the next slide, we have a comparison table which it shows all the models from the SI series. So this is a comparison table that represents the main characteristics of the camera, and we can see their usage and differences, of course. As David was talking, we were focusing more in the SI2 series and the SI1 series. So you can see in each of the different models what are the available modes. So, for example, in terms of Pro, you can have the 3 modes, which is leak detection, mechanical fault detection, partial discharge. And as you can see, the determination of the model it gives a hint of what are the modes which are the cameras are meant for. In terms of PD, well, those are meant for partial discharges. In terms for determination LD, that's for leak detection. So in this case, we have in this comparison table at first to make a difference between what are the modes in each of the cameras. Then another important point is the minimum detectable leak rate. So this is one of a specification that means what is the camera sensitivity, or how small leaks the camera can detect. And of course, we have for the SI2 series, from the SI2X as well as the SI2, we have the best minimum detectable leak rate. So you can see that it's 0.032 liters per minute.
0.00.
Yeah, 32, yeah. And you can see that this is one of the specs that, well, of course, is for our premium cameras, and this is a very sensitive information. Leak rate.
I would like to remind, because Abraham is very well pointing out this 0.0032 liters per minute. This is a very small leak size. When checking specs, when you want to compare cameras of different models, different manufacturers, please always check the camera in practice, the camera in action if you can. Make them to be head-to-head. Compare cameras, because the performance is very important for you use. So another addition to this comment is our cameras work on this, like they have this kind of the minimum detection threshold of 0.0032 liters per minute at 2.5 meters. This is very important. Of course, if you have a higher distance, the detection threshold is smaller, is bigger, so it's high, it's like this bigger amount. And if you get a bit closer, it will be a bit smaller even. But that's a reference level. So if the reference level is 0.0032 at 2.5 meters, this is our standard reference level. Sorry to interrupt.
No. And yeah, basically you can see that there is consistency in the SI2 and the SI2X models. So we offer the minimum detectable leak rate at that point. Of course, the SI1LD, it has a very good minimum detectable leak rate, but of course this is different, and this is a different factor. So if you need more precise instrument, if you need to see smaller leaks, if you need to have, of course, the more capables in the distance, and among other functionalities, the SI2 series is I would highly suggest to pick that device. But this is a comprehensible chart where you can see pair to pair what are the differences of the cameras. And the two last features is the auto filter and auto distance, which these are important, very important factors, as David pointed out on site. So once you are demonstrating the camera, you don't have to care about switching your manual frequency selection, or you don't have to care about that. You are just performing your inspection, and your user experience is enhanced. Using auto filter and auto distance, we are offering in the SI2 series and SI2X series, and basically that's the main difference comparison with the SI1. And the next comparison table, well, this is a continuation, and this table is it's basically offered in the FLIR customer web support. So in the FLIR customer portal, you can find this information available for later if you want to check it later. So of course, the HAZLOG rated, which are the certified areas and very specific devices for atmospheric explosive atmosphere environments. those are the SI2X series. So in that case, that's the main difference between the rest of the models.
Just to mention as well that we are ATEX certified. We have ATEX certified camera, the SA2X Pro and SA2X LD. And we are now working on getting the certification of IECEX, which apply to many of the countries of you where you are located. So it's a very much used certification in those countries. So we will get the certification very soon, hopefully, in a matter of a couple of months.
Okay. And both or all of the models are compatible with our offline and online solutions. So for FLIR Thermal Studio or the acoustic viewer. So if you want to make any reporting, any share the information, share the snapshots, everything that these two software empower the capabilities of the camera, those are available throughout all our models. And the next characteristic is the frequency range. And as David pointed out previously, the frequency range is expanded in the SI2 series, and that's mainly because the type of phenomena that we are capturing, the type of applications that we have. So you can see that, for example, the SI2 LD, just as a reminder, that has leak detection as well as mechanical detection. So we have expanded capabilities in the frequency range. Whereas, for example, the SI1 LD for the type of application that is very specific to spot compressed air leaks is 2 to 100 kilohertz. So that's the main difference. And of course, the detection range. So you can see that the SI2X, the SI2, is up to 200 meters, whereas the SI1 at the moment is up to 130 meters.
Yeah, now I guess it's clear. So we were now we are moving to the slides ahead. We just want to show here the user interface for the different modes. So here we have the user interface for PD, for partial discharge, and this is the way the user will actually see the screen in most of the cases. So basically, we'll recommend them to use auto filter. As you can see, they have auto filter there. And when the camera spots, as you can see the blob in there, a partial discharge, it will also show automatically on the screen the PRPD pattern, which is actually shown here in the kind of center left side of the screen. So that's actually the kind of certification of that specific phenomena picked up by the camera. It's a partial discharge. So camera is showing the blob, so the sign there, and also the PRPD pattern. And that's actually telling the user that there is a partial discharge in there. And of course, we have all the different features in the touchscreen here, as you can see. As I mentioned here, you can also activate the manual frequency selection filter, which will open a frequency selection kind of bar in the top side of the screen. But we didn't want to show it here because we wanted to show the auto filter mode.
And as another comment, you can see also the analysis result box, which it shows the dB level and also the type of partial discharge. So in this case, our camera is the top leader performance in the PRPD or partial discharge detection. And one of the important characteristics is that once you spot a PD outside, it gives you information like what kind of PD and also the severity assessment. So all these capabilities are offered in the camera, and you can see right away the results, and comprehensively you can take actions in the right direction right away.
Yeah. We're just waiting for the computer to react. Yes, now. We have now here the user interface for leak detection. So if you go to leak detection mode, you will have a user interface as such. Now, To differentiate from the previous one, we have activated the manual frequency mode. As you can see, it's activated in the right side, and you have the bar, the frequency bar up there, where you can actually select with your fingers. You will be able to move that frequency range up and there, and actually have a bigger, for example, frequency range. This narrower one, you can actually decide how you want to actually use the frequency selection of the camera. In the left side, again, we have the analytics information given on the screen, and we have, in this specific case, the decibels level, so the SPL, sound pressure level of this specific leak formed by the camera, and we have the cost estimation in dollars per year. In this case, you can select whatever units are fine for you, and you have here also the leak estimation, the leak size estimation, and the leak type as a reference for yourself. If you selected air, the camera will actually keep air for there as an informative information. If you select other gases, the camera will actually give you the same data for other gases. If the gas that you're looking for, whatever gas it is not present there in the list, you will find the leaks in any case. Now we are moving to the next slide. Yeah. So this is the user interface. This interface screen look and feel for MEC mode. In this case, we have similar characteristics. As you can see, we have a common kind of a screen design for all the different modes. We don't have auto filter for MEC mode. This is one thing to reference, but we do have actually the frequency path for manual frequency selection, but we disable it here because we want to show it in a different way. So as you can see, we have the normal filter, which is kind of covering lower frequency ranges from 20 to I think it's 40,000 or so around hertz. And in the left side again, we have the box with the insight of the finding. So decibels, so sound pressure level of the MEC fault, potential fault detected sign, so which is like, this is kind of a proof sign. So if you find something, but the camera doesn't show you this message of potential fault selected, it means that the camera is not recognizing it as a mechanical fault. Okay. So we have crest factor and kurtosis, which are two statistical, data that are actually using normally in mechanical fault detection and evaluation.
And as David pointed out, we wanted to depict in the different user interface screens different type of scenarios. Of course, highlighting the type of application that we are using in each of them. But for example, a little bit more advanced, we can demonstrate the different type of filters that we are utilizing in the different types of cameras. So in the first one, it was auto, which it was the adaptive filter. You don't have to care about your any type of environment. You automatically the camera automatically selects the filter. The second one was the manual frequency selection that gives you freedom to inspect in whatever area you would like to see phenomena. And in this case, those are the regular filters that we are using. In this case, we are using norm filter, which it filters out any disturbances from the environment, and also it selects or it has a specific range of frequency. So it's not adaptive as the auto mode. And regarding to the analysis results, so for example, the partial fault detected, we're gonna explain this in a bit more detail later. So just as I mentioned.
Now we are moving to the next slide. Yeah. So this is a briefing of our acoustic product mix. As you can see, we have the kind of, let's call it volume line. So cameras with one mode for leak detection with a bit less specific features, but really powerful in terms of like usability and playing characteristics in our, you know, like being part of our series. So SI1 LD. Then we have the premium line, which is like covering the SI2 cameras, SI2 LD, SI2 PD, SI2 Pro, which the Pro is covering all the different modes and features that we actually have for our acoustic cameras. And then we have the SI2X, which is our product line for hazardous environments, for the use of acoustic cameras in hazardous environments. So the cameras are ATEX certified, and we are now about to get the IECEX certification, well, very soon. So basically, this is kind of a display of our product mix. Well, this is what the box is actually. Well, this is not shown here. Yeah. Okay. This is basically what our box are having when we are delivering a camera. As maybe we just need to highlight here that you will get the acoustic camera with hard box, a hard case that will actually allow you to bring it everywhere in a safe way. You will have a license for Thermal Studio. If you want to use our cloud, you can use our cloud for free, so you will be able to use the FLIR Acoustic Viewer online and the Thermal Studio. Yeah, and you will have 2 batteries and the battery chargers and the USB memory stick, and then we of course have 2 years of warranty. Now we're jumping into the camera modes and the scopes of use. Yeah. So focusing first in partial discharge detection, maybe Abraham can take the lead here.
Yes, so partial discharge is one of the main applications that we are solving with the camera. So partial discharges are a usual phenomenon in the electrical systems. So the partial discharges can appear, for example, as a minor failure, but this will always escalate and progress even to a complete breakdown. So of course, partial discharges are occurring in different types of components of, specifically in medium or high voltages. And for example, we are taking into consideration an insulator. So the type of insulator, well, the PDs can occur in different types of the medium. So it can be on solid, air, gas, vacuum, or liquid. And from this also, those are categorized. So they are categorized mainly in the literature: corona, floating, surface, and internal, depending on where and how they occur. So common causes for these partial discharges are, for example, surface contamination, and that can be, for example, the conditions of the environment, humidity, dust, just the conditions of the environment. But also it can be, for example, for material manufacturing and installation defects. So in case that while manufacturing one of the components, it was contaminated, for example, or it didn't. It can produce some failures in the future. Any mechanical damages, for example, for wear or tear due to electrical stress. So yeah, basically the partial discharges is a very common issue that is existing in the industry and we're solving it.
Yeah, this is an example of like PD report. Of course, I just made it up a little bit, so I put it in different order. But basically, as an example, you will be doing your own inspection. You will find a partial discharge. This is, you know, this is a cable termination in a HV tower, where you will basically see this block. You will take a picture. You will get analytics. And then after you have got the analytics, you will get, of course, an evaluation of the partial discharge, of typification. So in this case, it was surface or internal discharge, and the severity level. As you can see in the low right corner of the screen, we have the severity assessment. This is shown. This is displayed in camera, so you will have direct access to this information in camera. But then also in cloud, you will be able to edit it. For example, if the voltage of the system that you introduce is wrong for any reason, you want to correct it, you can introduce it, you can change the component type, or for example, the environmental characteristics like you know, humidity and temperature, or the distance you can correct. So basically, you would be able to have direct reporting and information on a screening camera in field, but then you will also have this information in the cloud once you connect with your tablet or with your computer, and you will be able to actually edit it and create your reports. So as a briefing of what we are showing, or how we show our data, this is the way, basically. So we have 3 user inputs expected from any user, which are distance estimation up to 5 meters. Of course, if it's less than 5 meters, the camera automatically calculates the distance. But of course, in partial discharge, normally you need to take some distance. So it's not so easy to work like in short distance, but it's not basically, you cannot work in short distances. Then the voltage. So we expect you to know the voltage, or the user to know the voltage of the system. And this is fundamental for the analytics. And then the typification of where the partial discharge is located, the type of component where the partial discharge is located. So once we give these 3 inputs to the camera or to the cloud, the camera or the cloud will actually throw this information, or will calculate this information for you. It will give you the severity level, and it will give you a description of the type of partial discharge and a recommendation. If we talk about the typification of the partial discharge, you don't need to give any inputs like this to know the type of partial discharge, because the camera identifies the partial discharge analyzing the PRPD pattern. There is not any kind of secret there. So basically, we identify the partial discharge by understanding the wave of the PRPD pattern. But then if you want to get severity level, description, and recommendations, you need to introduce this data to get it sharp and correct. And now we are moving to leak detection, where, as a reminder, we have a bunch of cameras that can work for this. So SI2LD, SI2 Pro, SI2XLD, SI2X Pro, and SI1LD with different characteristics and advantages and features. As a reminder again, because we have mentioned this, when we look at leaks, we look at pressurized leaks. So those leaks that we find with our cameras are leaks of any gases or compressor or steam that are actually under pressure conditions. The camera basically finds leaks in audible range, which is from 20 Hertz to 20,000 Hertz, and then ultrasound range, which is like over 20,000 Hertz. So sometimes there's also maybe not misconception, but there's a common place in the industry where people are talking about ultrasound cameras. It's actually not exactly like that. It's ultrasound and audible range cameras. So basically, our cameras work in both in audible range and an ultrasound range. So that's why, for example, you can sometimes find a leak or a PD that you can hear it yourself. Otherwise, you will not be able to hear it. So that's why you can go and visit a substation and find like there is a sound that you can hear it, and it's because it's in also performing in audible range level in between 20 and 20,000 hertz. And yes, of course, these cameras are like aimed to work for industrial maintenance, regular inspections, to prevent energy loss and equipment damage. They are safe. Also looking at safety, safety by finding dangerous leaks in industrial facilities. You can imagine that, for example, an oxygen leak in some specific industrial facilities can be extremely dangerous, as an example. And quality, of course. Leaks often represent a drop in quality or a quality problem in many industrial processes. So we need to be fixing them, and we need to have them under control if we don't want to actually start falling into quality issues with our customers and our final product. Now we're moving into an example of a leak. Well, this is actually in Italy. I can say I was there. I was taking that image myself. This is, as you can see, this is a paper machine with full of pulp. It was a very noisy place. You have visited a paper factory in the paper machine rooms, which are really big machines normally. There's a lot of noise, a lot of steam around, and it's really humid, of course, because there's a steam. So this is an example of a leak that if you do an inspection and you find in these very challenging environments, if you find like, I don't know, 10, 15 leaks, and you can actually fix them, this is compressors, you can fix them quickly, you will basically start saving money from the minute one. So that's why we always want our users, our customers, to handle the camera and go and find the leaks or find the phenomena they're looking for, because the cameras are extremely well performing even in the most challenging environments. This is another example. This is a chlorine leak in an industrial facility where they knew that there was a chlorine leak because they were actually smelling it. They could smell it, but they didn't know exactly what it was. And they said, of course, they can use other, like all methodologies, but they said, well, we can check with the camera now because we know that there is something going on here. And basically, of course, the camera will automatically find it because it's a pressurized leak. So the chlorine is leaking there, and the camera will tell you where it is. We don't have chlorine among our gases listed, so we don't have quantification on the screen of the leak size. But it doesn't prevent the camera from finding the leak. So that's why I always insist on this. Many of the users need a camera to find where the leaks are and just fix them, especially we are talking about industrial gases. So for this purpose, the camera works perfectly, even if it's a very rare gas. The camera works for pressurized gases finding as well. And now we are moving to mechanical fault, and maybe I can give the word to Abraham.
Yes, the mechanical fault detection, we have also a variety of models. But basically, the SI2LD, SI2 Pro, and SI2X Pro. So basically, the mechanical fault detects varying faults that this is a very common failure or very common issue that in some of the facilities they have. So constant wear and tear can cause that the conveyor system and in their components such as bearing and idlers. So this can deteriorate for different type of reasons. And well, basically we are detecting and addressing to spot them and identify the location where these components are having a fault. So the ASI2 mech mode, the mechanical mode, reveals the faults by measuring the noise and also getting more information on screen. So we have the sound pressure level, we have kurtosis and crest factor, and we have also the newly introduced mechanical severity assessment. So in the next one, this is basically the interpretation of the metrics, of the key metrics. So similar to our different type of applications, we want to provide the users to a very practical way to spot the failures and to know that there is a failure in that specific component. So that's what we are we introduce mechanical severity indicator. So this is an algorithm basically enhanced by the AI of our camera that detects the unevenness and friction for potential indicating faults. So as shown in the previous screen, you can see that there is a potential mechanical failure, and you can see the results of the camera. So this is one of the things to interpret this type of metric. Of course, we know that in the mechanical failure, there is more information to take into account because most of the times we are comparing between different types of elements. So it's very, very important that you make a comparison method and compare good components, in good condition, components in good condition versus components that are presenting a fault. And that's why we are introducing the SPL, crest factor, and kurtosis. Of course, we have a metric, for example, values of 6 or higher in terms of crest factor, in terms of kurtosis, values over 2, for example, might indicate the variables. But this is for supporting the information that you are having. So just as a tip, always compare this crest factor, kurtosis, and SPL for to know the healthy of your mechanical component, in this case the bearing. And then we are going to the next one, and this is an application. So
no, I mean we are running out of time, so that's why. Yeah, basically, this is another example of a conveyor belt. So as Abraham is explaining, we cover conveyor belts, so bearings, rollers, in any kind of industry. We also cover gearboxes, engines, or any kind of rotational elements in systems where they can actually represent faults. So we want to go ahead because we don't want to go over 1 hour. So now covering the FLIR acoustic viewer, this is our cloud for any user. Maybe you can explain it if you want.
Yeah. So as mentioned, we have this powerful tool for reporting, for example, or to perform different actions. So once you take the snapshots on the camera and you want to put this information available online, you can do so. So you can sync and automatically upload the snapshot from the camera via Wi-Fi, or if you have, we have also importing the USB, you can do so. You can edit, save snapshots online, and this is completely free, and there is no limit in the storage. So you can use this platform in a very flexible way. Further actions you can do, for example, share a snapshot of files and generate reports in just a couple of clicks. Create a PDF, for example, compliant with ISO standards. Also, if you want to export your data in Excel for customized dashboarding or using any different types of user your information in different way, you can do so. You can organize your snapshots for direct retrieval and access by using different types of tools that we have. And also you can track, for example, in terms of leaks, when it's detected, if you check a box and you for each of the snapshots.
Yeah, so you can track the time from leak finding to leak fixing.
And the next one is enabling the enterprise customer scaling. So for our large customers, we offer a set of tools also to expand on their capabilities. So in this case, if they have more than one camera, there is these tools that is fleet management, for example. So you can actually see where your cameras are in different places or in different plants. Also, the data organization. We are allowing that groups of work, they can share the same information and they can distribute this information among the team. And or of course, the supervisor can also have access to this. And we have also the connection API. So in this case, if there is a need that a customer prefers to have directly the information from the camera to their cloud or their own system, we can use the API.
Now we are moving to the next slide.
Yeah, and this is basically the difference between the offline and online solutions. So one of the biggest advantages, for example, from Thermal Studio is that you have a custom report template and freedom. So you have different elements and different arrangements to how to customize your report. Also, you can include infrared and acoustic images in the same one. And also, well, of course, your storage location is in terms of offline is in your computer. And in the acoustic viewer, of course, it's empowered by online capabilities, for example, the organization model or the API integration, as well as the allowing multiple cameras or multiple users to see the same data.
So, if we would like to summarize, we'd like to mention as a final remark, our general competitive advantages. So we have easy to use solutions. So easy to use solution advantages are not only about requiring a minimal training, which is actually true. Our cameras can be just used by anyone by handling them and going to do the inspections after a couple of minutes of explanation, but also finding the phenomena, whatever you're looking for in a first glance. So you have an easy to use solution. The camera will spot what you're looking for, and you will have a minimum risk of not finding what you need to find in your systems, in your facilities. Then we have deep and elaborated insights with on-camera analytics. So we have insights, analytics, very advanced analytics in cloud, but also in the camera. So basically, you can react quickly while doing your inspections to those phenomena that they need a quick reaction. We have on cloud powerful reporting tools, which is like a big advantage. So you can create your own reports for your organization and your people, your colleagues, your team. You can share information for the board with the board in terms of, for example, like return of investment of the cameras or cost saving, and you have unlimited storage in cloud. So basically, you don't need to buy any extra licenses of cloud when you are using the cameras more and more and more. We have some customers that have like 70, 80,000 snapshots from inspections, and it's growing and growing. So yeah, so unlimited storage. Camera is performing in a scalable way for enterprise use level, as Abraham was explaining previously. The one-handed and lightweight devices, it's a big thing in terms of safety. Leaving one free hand for grabbing, holding, protecting yourself in any kind of extreme situation in factory. And then, of course, we are really serious about data protection and compliance. So all the data, it's in certified places. All the information is in safe places, and this is not shared with anyone but yourself. And then, well, the cameras, of course, this might depend on the market, but for us, it's a big thing. The cameras are made here in the European Union, in Finland specifically. So where we are speaking from Finland actually today. Yeah, so this was our final remark. Thank you very much. Thank you for your attendance. I will check now if we have any questions here.
Some questions
I can thank you for taking the time, and sorry about the it's a very passionate topic for us, of course, for David and I to present you this type of information. And thank you for hanging up. We can take the first question. So, can the SI series be used in -30 Celsius cold room to detect leaks along the doors and ceiling caps? The camera capabilities have limitation in temperature, so the minimum temperature that they can be used is -10 degrees Celsius. So in that case, we are not capable to, or the camera not being capable to use in that cold environment. The number 2 is how SI2 determine the severity category, the PD analysis, and what parameters are used in the severity analysis. So this is a very important question. As mentioned in the previous slides, most of the processing is performed by the camera and the AI capabilities of the camera. So the AI capabilities of the camera is constantly in real time sensing the environment and sensing the signals and analyzing the type of signal. So the type of signal, for example, is categorized into different type of partial discharge detection. But to refine this analysis and extend more accurate recommendation and severity assessment, we need 3 parameters, which is the distance, the voltage, and the component. So setting up these 3 parameters will approach more the recommendation and severity analysis that the camera is providing.
Maybe adding something to this, because this is a very important question. So we identify, and this is kind of a big advantage for our cameras. We show on the screen, and the camera automatically identifies the PRPD pattern related to this specific partial discharge. Once the PRPD pattern is identified, the camera determines, our analytics determine the type of partial discharge. Once you have the type of partial discharge, as Abraham said, in combination with the type of component where the partial discharge is located, because it's fundamental, the voltage, and of course the distance to kind of estimate the sound pressure level impact. So how high is the decibels level of the partial discharge captured by the camera? Then we can determine the severity level of the partial discharge. And this is basically, there is no secret in there. Of course, the only big secret behind this is a matter of many years of gathering data from millions of inspections, where we have been sharpening our analytics. And we have been getting better and better in giving extremely sharp severity assessment. But basically, this is what we are combining for our calculations.
The next one is there a certification requirement for the acoustic imager operation?
No, there is no any kind of a standard certification for acoustic imaging in place in the world, to my understanding. So maybe I'm wrong, because maybe they have something new. Of course, there are different certifications that apply to the use of our camera, that we are getting the certification for different markets, like international certification from ISO for like a quality or reporting or any kind of certification. Those we do have in place. But specifically for acoustics, no. Maybe Abraham wants to say something.
Yeah, there is, until our knowledge, not yet a certification, but there are supporting literature that you can check, and ITC is one of the places that they can offer. They offer these courses. So the Infrared Training Center has available supporting material to for this.
So it's the same question. You see the last one. You see similar to thermal scanner one below one. The last one. It's the same person.
Yeah.
So you were right.
Yeah. So you can check, for example, in ITC they have supporting materials, but we're not sure yet if this is a certification or not.
But it's coming actually. I think I can say this. Hope so. We are working on on courses with the ITC, well, working, helping them. We are exchanging information, and they will soon, I believe, have certification courses.
Then the next question is, can the SI2 detect fault or leak that blocked by an object or not in the line of sight? Well, this is also a very good question. So the camera needs, well, because of the type of phenomena that we are capturing, which is sound and ultrasound, the phenomena or the waves, the sound waves or the acoustic waves need a medium in which they have to propagate. So this medium should exist. So in case of, for example, we are having questions regardless, like, oh, there is a electrical cable underground. We don't have capabilities that, for example, sends that kind of signals because it's on the ground.
Any acoustic camera, no acoustic camera can find an underground cable or partial discharge.
Exactly.
But then again, what you're saying, if, for example, if we are in a high voltage cabinet room with cabinets that are closed, actually, if in the joints of the doors of the cabinets there is room for the sound to stick out, to come out from there, the camera will spot that there is something there in the joints. And then if you open the cabinet, then the camera will tell you exactly where, for example, if there is a partial discharge was. So if there is not direct sight, but the sound come up somehow, as we can actually also find reflections in many places where maybe you need to look them for the real like leak or partial discharge. If the sound can come to you by reflecting or going through some places, yes, the camera can find it, even there is not a direct sign. But if there is a clear blockade of the sound, so where the sound cannot come out from there, the camera will never be able to find it. No acoustic camera. No.
Yeah, and also take into account that, of course, we can use in reflections in our advantage. So many, for example, of our leaks that they can detect on site can be for reflection. So you can see on the reflection, and then you can trace back, and you can actually spot where the leak is coming from. So yeah, this is kind of similar principle, and this is one of the examples that we are providing, of course. How long the battery will last? Well, this is 2.5 hours. We're just going very quickly towards the last one because we know that
we have two batteries with every camera, 2.5 hours per camera, and the cameras are coming with a battery charger. So basically, you will be able to be charging while you're using the other one. Then about the contact information, yeah, I will say you can contact FLIR in Asia, basically, or in Asia Pacific, depending on where you are located, and you will be able to actually they will readdress the questions to us, or if there's any kind of inquiry that we need to take care of.
Yep. Then the next one, can the camera be used to predict wear or tear of conveyor tracks, or they will only highlight once there is an issue? Conveyor tracks, well, basically it's on the element. So the presentation that we are talking about is about the bearings and the bearing elements. So those are mechanical elements, and yeah, it spots pretty much. And but as mentioned, right now we have the mechanical severity indicator, which it shows a potential fault, and as well as the kurtosis and crest factor. So in that terms, you have to interpret a bit more the metrics.
Maybe adding to this question of conveyor tracks, the camera will be able to spot, for example, an issue of, or well, differentiate element that has a higher SPL, so decibels level, which actually be a sign, for example, of lack of lubrication. If there's not so high SPL difference. So basically, yes, somehow the cameras will be able to spot where there is a difference in between the SPL of the difference element around and the specific element. And you will know that even though the element is not broken, it might just need lubrication. So depending on the system, this is a very general question and answer for us, but yes, it will. Yeah.
Then the next question, can the SI Pro detect leak in gas or steam turbine that is covered with insulation?
Depending on the insulation, if it's a really good insulation and the sound cannot come out, no. If it's kind of insulation for protection, maybe yes, depending on the insulation nature.
Yeah. And I think pretty much that's all the questions. We really appreciate that you stick in for the Q&A and also very interesting questions, and we appreciate also being here.
Yeah, thank you very much. Thank you to everyone.